on, graphing polynomial functions. We're not doing just a quadratic anymore. We're going to branch off into higher degrees. Today you have 9 problems, I think we decided it was. 3 of them are just, actually 6 of them are pretty basic. And the other 3 are a little bit more work, but not too much. So we've got graphing polynomials, and we're going to be doing higher degrees. Some review vocabulary, standard form. You know this.
You need to write down.
Well, that's up to you. Okay. Standard form, you should know this. Is this in standard form?
That is not in standard form.
If that is not in standard form, what is wrong with how I have this written?
It's not arranged right.
It's not arranged right. Arranged right would be what?
2x cubed minus 4x plus 9.
Highest degree first, right? On that. Did you already know that was standard form? Okay. Did you know that was the name for it?
Yes.
Okay. If you didn't, then maybe you need to write standard form down. If you did, then you don't need to. But do you know when you see a polynomial that you should put it in that order? Yes. Good. So, using this, the leading coefficient is the first non-zero factor that is multiplied by the greater power of x. It's a lot of words to say the first number is 2. That's the leading coefficient, right? Sometimes when there's no number, what is it? A 1. Okay? The degree of the polynomial is the greatest degree of any of the terms. So it doesn't have to be in standard form to be able to tell me the degree, but is it easier to tell me the degree if it's in standard form? Yeah, because what's the degree of this polynomial? 3. Because that's the highest exponent. Okay, if you want exponent rather than the greatest degree, if you want the greatest exponent, can you put exponent in there?
Yes.
Yes, it's the same thing, isn't it? So notes are for you to use later. So if you're not understanding what you're writing down, is it any good to write it down?
No.
No. So I have 2 examples. And it says, write it in standard form, tell me the leading coefficient, the degree, and the number of terms we have. Jane? Write it in standard form.
3x to the 4th.
Nope. Look at your 3x to the 4th again.
Negative.
Negative 3x to the 4th. Then what? Okay, how did you know this was a plus 2x? Because there's no negative, right? I get that question every time I teach this stuff. How did you know it's a positive? Because guess what? There's not a what? Negative. Because if there's a negative, it has to be there, right? Okay, so I'm going to put LC. What do you think LC stands for?
Leading coefficient.
Leading coefficient. Somebody's like, the greatest common denominator, or least common denominator. I'm like, no. First of all, there's a D in that. Okay, what is the leading coefficient?
Negative 3.
Negative 3. Negative is important. What is the degree? We're going to abbreviate that with the D. Can we do that?
I suppose.
Unless you want to write a degree out, go for it.
I might mix it up with so many.
Right.
I'm really confused.
Okay, what is the degree?
4.
4.
Somehow.
Where did I get the 4?
From that.
And there's leading coefficient and the number of terms. Form. Now, the number of terms has nothing to do with the degree. They just happen to be the same, correct? Has nothing. They do not affect each other in any way. So, how about you do the next one all on your own?
Okay. Fine.
What's the D mean again?
Degree.
And degree is just exponent.
The largest exponent.
Okay.
And if you put it in order, then it would be the first exponent you get. So that's why putting it in standard form does help you out some. Someone who has it done, would you like to come write the answer on the board? Go for it, Garrett.
I'll
Can I bring my paper?
Yeah, you can remember it.
No, you have to do.
So how did you
Come on,
know
I wanna
for the
ask
first
you.
one that negative 3x to the fourth was the first one to go?
Because it's the highest degree. It's the biggest power.
So the leading coefficient and the degree should be the same.
No.
Wait, no, never mind.
No, the leading coefficient comes from that.
Whoa.
What about the term?
Wait, what's the degree?
How many?
Oh,
The highest.
The highest exponent.
okay, yeah.
The number of terms, I should put number, is how many terms. They're divided by addition, subtraction. Remember?
You should
No.
put NOF.
Should I just put N dash O
N-O-F
as
number
of?
You could just put
NOT.
hashtag T.
What's that?
Oh, yeah.
Number of terms.
Should I just put N dash A for this, for that? Is that-
A.
I'm just going to put T.
No,
I was
I
gonna
mean
do.
for the answer, like N dash A, not
Applicable? No.
Not that, go that word.
Okay, so did you put it in? 2x to the 6th plus 5, x to the 5th
Yes.
minus 3x to the 4th plus 4x cubed minus 8x.
Yeah.
Yes. What if I had something that like another x to the 6th there? What would I do first? I'd combine them, wouldn't I?
Hey, yeah.
Should I always combine like terms?
Yeah.
Thank you. Okay, so where did he get leading coefficient of 2? The
That's
2x to
the
the
beginning.
6th. The highest degree is what?
6.
6. And the number of terms is? Oh, I disagree with your 6. 1, 2, 3, 4, 5.
Oh,
Okay. 1, 2, 3, 4, 5. Terms are separated by addition, subtraction, not multiplication. Because think about this. Can I multiply anything I want no matter what it is?
Maybe.
Yeah, right? Can I add anything I want no matter what it is?
Yes.
No.
Why
Can
not?
I add x and y?
Yes.
No, I cannot.
Yes,
But
if you
can I
solve it
multiply
using
x and y?
Yeah.
Yes.
Wait. Why couldn't you? 'Cause didn't you just
They're
solve
not
it?
the same. You can't add x and y because they're not the same. But you can multiply unlike things.
You could technically add them.
No. Not until you know what x and y is.
Well, yeah, that's what I mean.
Okay, but we don't know what they are.
But what if you find them?
Evan,
Well, then you can add.
you're getting us off track that doesn't have anything to do with third degree. You cannot combine things that are unlike. You cannot add or subtract them.
Okie dokie.
Okay, so any other questions about this?
No.
So we're going to go to the next thing. Now, there's a lot of stuff. Please do not just start writing. Okay? There's a lot of stuff here. So we need to understand what we're doing. The big red arrow might be the key words that we need. Yes? Okay, we are going to be talking about the end behavior. Okay? So, what end behavior is, it describes what is happening to the y's as the x approaches positive and negative infinity. And actually, it starts talking about only positive infinity because we do everything from what direction to what direction? Left to right, correct? Negative infinity to what?
Positive.
Positive infinity. So if you really think about it, it's telling you what's happening at the end, which would be positive infinity, and then you figure out what happens on the negative infinity end because of what type of things we have. So what we need to know is that when we have an odd degree, what's an odd degree? What's an odd number? 1, 3, 5, 7. Okay. But first we have to be in standard form, okay? This is the degree of the function. We just got done doing that, right? Okay. Go back here. What degree? Odd or even? Oops, odd or even? Even. Odd or even? Odd or even? Even. Odd or even? Odd. Got it? That's what I'm talking about. So if I have an odd degree, positive leading coefficient, my graph ends up, and it's odd, so it's going to start down. So it ends up, starts down. So, what is the degree of just x? Besides it telling you it's 1, correct? Is that odd? Yep. And what's the leading coefficient of x? 1. Is that positive?
Yeah.
Yeah. So it's odd positive, so it's going to end going up, so that means it started going down. So 3 is odd, yes. Is 0.5 positive or negative? Positive. So it's going to end up and start down. This tells me nothing about the middle behavior. Nothing at all. Okay? It only tells you, when we did parabolas, I did open up, open down, yes? We did open up, open down. We were just talking about the end. We didn't know anywhere where the vertex was or anything like that. We just knew up or down. Same thing. Okay, so 5 is odd. Yes? 2 is positive. 2 is positive. So it's going to end going up. So that means it starts going down. I'm clear on that. Odd always start and stop in the different places. What do evens do? You should know this.
Wait.
So parabola is even, correct?
So it
Starts and stops in the same direction, yes? So if the degree is even and the leading coefficient is positive, it is going to be up, up. We've done that before with parabolas, yes?
Will we have any graphs that have like this squiggly lines? Like
Well, we will have some graphs, we'll do that in a minute, but we're not going to get, our graphs are going to be estimates of things going on. At this point, you are not going to be getting into specifics.
Okay.
So another way to write this, it says as x approaches negative infinity, so that's to the left, right?
Yeah.
Y is approaching what?
Positive.
Positive infinity. And as x approaches positive infinity, y approaches positive infinity. So this is technically the math way to do this.
Yeah.
Okay, but guess what we're going to just do?
Not do it.
Up, up. Down, down. Up, down. Down, up. So you can, now what do you really need on this?
What do we really?
What do you really need to write down on this, on your paper for
Odd
this?
degree
The
down,
odd and
even degree up.
The odd, positive,
And the
even positive, and where it approaches, where it goes. So you guys let me know when you're good. Now this is called the leading coefficient test. Why do you think it's called the leading coefficient test?
Because you have to test it.
Because that's what we're looking at, right? We're looking at that leading coefficient and the degree of the function to tell me what the graph is going to do ultimately. Okay, so we only talked about positives. We need to talk about what? Negatives. So go ahead and write on your paper, those of you who are done, you're going to have an odd negative, yep? And you're going to have an even negative. You should know one of those answers already. Which one should you know?
The odd, the even,
negative.
negative.
You should know the even negative.
Down,
Down, down. So why don't you make a guess? What?
Why does
Up,
it go
down.
It starts up and it goes down.
Okay, is everyone done with this one?
Yes.
No. Austin, are you done?
Yeah.
Okay. Okay, so here's my next one. So when we have odd negative, it ends down, so that means it had to start where? Up. And when I talk about ends down, that means on the positive side, right? So everyone gets that. So then even negative is down, down. Even numbers are 2. What else? 4, 6, 8, 2028, right?
Anything that ends up
Anything that ends in an even number.
20, 22.
Or 0, yes.
26.
Is 0 odd or even?
Even.
Neither. Is it prime or composite? Neither. Is 1 prime or composite? Neither.
Actually, you know what?
1 is neither. And they will
0.
put that, what?
0 would technically be even because if you go by all of them, they're all going by 2s. basically. Like,
0 is neither.
So what
one,
is 0?
two,
Just
three.
0?
0 is just 0.
Evan, stop saying
And-
technically to the math
And I'm
teacher.
going to tell you with the 1, guys, they will put that on standardized test things. They will ask for prime numbers between 0 and like 15 or some number. And when you put a 1 down, you've basically failed the question.
Yep.
Because the definition of prime is 1 in itself goes into it, right? So 1 is just one number. So 1 is neither prime or composite. Just little tidbit. And they put it on tests and they think it's fun to see if you know.
Yay.
And it's so arbitrary. Okay, so we're gonna do a little dance right now. I'm gonna say some numbers, some odds, some evens, some positives, some
Yeah.
negatives, and you're gonna dance for me, okay?
Oh.
You're gonna dance for me.
Action.
We're gonna disco. Okay, so I want an odd positive.
A what?
An odd positive. Do it. You got 2 arms. You got 2 ends. Odd positive. What's it look like? Is that what you got?
Yeah.
Okay. Odd negative.
Negative what?
Odd negative. Even positive. Odd positive.
Wait, what?
Odd positive.
Oh.
Okay. Even negative. Odd negative. Positive even.
I knew it was
Breathe.
Negative even. Just trying to guess what I'm gonna say, aren't you? Positive odd.
Oh, I had.
Positive odd.
Oh, that didn't make sense in my mind.
So odd positive. There you go. Because I switched the order, right?
I still got it. 'Cause
Okay.
I guess.
So when it's odd, I always say it looks odd. Why do I say it looks
'Cause
odd?
it's odd.
It's like a squiggle.
It's like starts in the stops in the opposite direction, right? Even should always be easy for us, correct?
Yeah.
But the key point is I'm always going to say it ends going up, so it had to start going down if it's an odd, or if it ends going down, it had to start going up. So I usually do the right hand before I do the left hand. Questions on that, guys?
No, man.
Okay, so I have 2 examples here, and I want you to, well, are they in standard form? Yes?
Yeah. Wait, yeah.
Yes, I think they both are.
Yeah.
Okay, it was nice there. I want the leading coefficient. I want the degree, the number of terms. I want an odd, even, positive, negative, and what its end behavior is.
Oh.
Can you write that down on the board?
Yep.
Could you?
Leading coefficient, degree, number of terms, odd or even, positive or negative, and end behavior.
What does the degree stand for?
End behavior.
I got all of them.
Got all of them?
I think I got it.
So Evan, do you want to write the answers up there?
So
Yeah.
even.
Do I have to write it? Wait, no, it's already.
Wait, so odd or even? What does that mean?
Is it odd or even? Is the degree odd or even?
Yeah, just circle.
Yeah, you can circle those, yeah.
Wait, what's the end?
That's a 2, not a circle.
3 points.
What's the end balance?
End balance and behavior.
End behavior.
Shut your mouth, Gail.
What's the odd, even? That's what you gotta have. So just do your arrows. It's hard when you stand in front of it. You can't see it, can you?
No.
It's not that easy to stand up there and do that, is it? Okay, you guys agree?
It's also
They
hard.
look like crow's feet.
I
Yeah,
can't,
I
I
was gonna
can't
say,
like
why do
put
they
my
look
hand on there because then it'll just block it off.
You know, it's even because the 2.
No, not the 2, the degree.
Six.
This is the degree. These are good questions you guys are answering. This is the degree and this is the leading coefficient. So leading coefficient tells me that and degree tells me that.
Yay.
Okay? So is it important that this is in standard form?
Yes.
Yes.
Yeah.
Okay.
So I got all that right.
I think I agree with you. You guys agree?
What's wrong with you?
I did it all in my head too.
Okay, all in his head. Okay, you guys got this one done yet?
Yeah.
Yeah.
Okay, I'll give you about 30 seconds.
Wait a minute.
Actually, yeah.
I got it.
I don't even have a problem right
Biggest
now.
of brains.
Okay, I'll give you 30 seconds on that one.
This clock?
So like about 20
Does that -5 make the 3 a negative?
Nope. Callie's gonna do it.
Yeah, Kelly.
She got it. Okay, Elsie.
-5.
Woohoo. Degree?
3.
Yep. Number of terms?
3.
Oops, that's a T. It's a pi. Number of pi. 3? Even or odd?
Even.
Odd.
But then 3 is even.
3's not even.
No, I thought you meant like if it's a negative or a positive.
No. Even or odd?
Alright, Callie.
I'm trying to call it 3 an even number.
Okay, Callie. It's all good. Okay, even or odd, Callie?
Odd.
Odd. Okay. Positive or negative?
Negative.
Negative. So what does the behavior do? What's my arrows?
Down, up. Up, down.
It ends down, so it starts up. Okay? We're getting it. We'll get it. Think about it, guys. Always think about what the right hand is doing, and then remember what the left hand does. Odd's always going to be opposite, correct? Even's always going to be the same. Okay?
You know, I think
What?
when a plane takes off, it goes from down to up, and then when it lands, it goes down to, or up to down.
So that would be an odd function that models the path of a plane? There you go.
Wow, Evan,
Well,
you're.
what if the plane came
I don't care.
Okay,
Technically.
So-
Technically.
What if it started up?
hopefully it's kind of a smooth curve. Okay.
Straight down.
No, it's just straight.
Just,
Just
I hope that's not the plane I'm on Thursday. Okay,
as long as it's
So-
over there.
now we have this. You have 2 problems. 2. Okay?
2 problems.
2 problems like this, and I expect you to do, it says, graph the polynomial function using points, identify turning points, relative min max, find the average rate of change over the interval to -2 to 0. So, first of all, remember, if I'm talking interval from -2 to 0, those are x's, correct?
Yes.
Yes. Okay, and average rate of change, does anyone remember what that's the same? Slope. And what is the slope formula?
MX plus
Y
12.
equals
MX
plus
one.
Yeah.
equals y1 over
B.
M equals y1 or y2 minus.
I1 over x2 minus x1.
So they gave me x's. How am I going to find y's?
plug your x in.
Plug your x in. And if you're smart, you put your x in your table, and then you don't have to calculate it more. Correct?
Yay.
On these problems, you can use a calculator if you need to, but use it when you need to, not when you don't. 2 times 5 is not a need for a calculator. Okay,
Yes, it is.
on your table must have 3 negative, 3 positive, and guess what else?
1 negative, 1 positive, 1.
3
Zero.
negative, 3
Zero.
positive, 0. Okay, so that's why I have 7 spots. So, I have 0.
You did.
And 0 is one of my x values I'm going to have to find, right?
Yep.
And the other one's going to be -2 and 2. Okay, so I'm gonna put, well, what values do you want to use?
Well, we should probably use one.
Well, we're gonna take 0.5, so that means half, right?
Yeah.
But everything we're gonna take half of, we're gonna take it to the 4th power before I take half of it, right?
Yeah.
So we're thinking we don't want to get too huge here.
2.
So 2.
But we're already using.
Well, we will use 2. We'll put 2. Do you want to use 1 and then 2, or just 2?
2.
2.
1 then 2.
1 then 2.
Oh,
So
come on.
don't you want to do -1 and 1?
Yeah.
Should we kind of keep it symmetric?
Yeah.
Okay, and then so then -2 and
2.
2
And then -3.
And then,
and then
negative
-3.
16 and negative.
and 3. Now, if I wasn't taking this to the 4th power, I would choose 2, 4, 6. Yes. Why would I choose 2, 4, 6?
Because those are even
They're
numbers.
even, and I'm taking half of them, right?
Yeah.
If I had a third of something, I would choose 3,
6, 9.
9. Okay. So be smart with what you're picking. Okay.
So
Don't make this overly difficult. Show me some work if you need to. Okay. So we have 3 cubed is
27.
27, and it's going to be to the 4th. Sorry. 3 squared is
9.
9. 9 times 9 is
81.
right? So that'd be 3 to the 4th.
And it's gonna
Yeah.
be-
Yeah.
So half of 81 would be 40.5.
40.5.
Okay, and it's going to be negative because I've got this extra negative out here, right?
40.5.
So negative 40.5. See, we didn't need a calculator for that, did
Why
we?
don't you put it
I
in
felt
the
like I did, but
Because we have to do the rest of the problem.
Oh.
Okay, so then 3 squared is 9 plus 3, or times 3, 27 plus 2. And now you can pull out a calculator. I think we could do this one by ourselves. So we got 9.
67.5.
Oh, wait. I added. I can't add. Why can't I add?
69.
because you told me I couldn't.
Why can't I add?
Because it's negative.
Because it's a negative. Okay, I'm just going to use my calculator just because I said I could. And I don't want to mess it up. Because this problem's going to take me long enough as it is, right?
Nope, it's 20.
It's 11.
Negative 21.5.
Negative 21.5?
Nope.
It's 11.
Negative 11.5.
Haha.
Oh, wait, yeah, no.
Okay, so negative 11.5.
Yeah.
So now what do I have to put in now?
What number?
Negative 2.
Negative 2.
Okay, so 2 times 2 is 4. 4 times 4 is 16. Half of 16 is
32.
8. And it's going to be negative 8.
Negative 8.
Does everyone understand why it's negative 8?
Yes,
Yes,
ma'am.
it is.
Okay, well, because last hour they were trying to multiply it first and then take the exponent. Our order of operations says what?
No.
Exponent first, then multiply. Yes.
Okay, can you go over that again?
Okay, so we have negative 2.
Yeah.
And it's 2 negatives makes a positive, so I'm just, okay, so 2 times 2 is what?
4,
And 4 times 4 is
16.
16. So that would be 4, that would be 2 to the 4th would be 16.
Okay.
Okay? So then, 2 squared is
4,
times 3,
12.
12, plus 2. So it should be 6.
Yep.
Didn't need a calculator for that one, did I?
Yes.
No, ma'am.
Okay, so 1. 1 squared, oh, I hope we just all say 1, right? Times, so it'd be negative 0.5?
Negative 0.5.
No.
Yes.
Yeah.
I'm
There's
just
5
kidding.
negatives up there.
Isaiah's wrong.
Plus 3,
Plus 2,
plus 2.
which is
So
just
we-
0.
It would be 4.5.
Wait, what?
0.5.
Oh.
Because 1 times a half would be
I
a
was
half.
thinking it was 5.
Yeah, no, it was 0.5. Okay, now, and 0. 0 should be easy.
0. 2.
2.
For 2.
Now, we have even powers up here, yes? So my negative numbers just all became positive regardless, didn't they?
Yeah.
No.
So what do I know about all these then?
They're gonna be negative.
They're gonna be positive.
They're going to be positive.
They're going to be exactly the same,
No.
yes?
Yeah.
So because they're all going to be exactly the same.
Wait. How is 1?
I'll prove it, I guess. Okay, so 1 to the 4th is what?
1.
Times negative 0.5.
0.5.
Negative 0.5.
Plus
1 squared is
One.
times 3 plus 2.
Yeah.
I think
Yeah.
you just put it in the wrong box.
Oh, I put it in the wrong
That's
box.
where you
I was
got
like,
me.
yeah,
That's
I was
why I
so
was
confused.
confused. I was like, why is it?
I was like, it's not wrong.
And then you said, I'll prove it. I was like, alright, you
Let's
show me
see
that.
this.
I did prove it.
All that equals a
I
negative
did prove it, I just wrote it in the wrong box.
I was so confused by that.
Okay. So this one happens to work out the same because what?
Cause
They're
they're
even powers.
Because they're even powers.
Yeah.
Okay, since they were even degrees, it's going to make everything positive no matter what, right? Okay, so now we're going to graph this. So I have -3 and I have -11. Okay, somewhere down there, 11 half. And then I have -2 and 6. And then I have -1 and it is
4, 5.
4.5.
Yeah.
And then I have
0,
2.
2.
0, 2.
1,
1.45.
2, 6. 3, 60. Or 11.5.
Okay, now everything you do is going to be an estimate, yes?
Yes.
Yes. Okay, so this is even, positive, so it's going to do what?
That's negative.
Oh, negative, sorry. Even, negative, so it's going to be down, down? No, even.
But it's a negative.
Even, negative.
Oh, God.
You have to do both. Okay, is this naturally what we see here going down? Down?
Yes.
Yes.
It's made in.
Now,
Math.
we want to find turning points. Now, do I know that -2 is like where it's changing? Like,
No.
do I know like if like somewhere between here it didn't go up a little bit more? Do I know
It
that?
could've.
It could have, but do I know that?
No.
No. So I know there's a turning point. Somewhere between -2 and 1, correct?
Mm,
Do I know that?
mm.
Okay, so I'm going to put -2 and 1, or -1, not +1. And there's also, remember that union? And is there a turning point somewhere?
0, 2.
Yeah, we don't know really between 0, well, -1 and 0, yeah?
Yeah.
Well, actually,
It'd be
-1 and -1 and 1, right? We don't know that this 0, 2 is my relative minimum, do I? But it's so somewhere between -1 and 1, there's 1. And then we know there's another one between what? 1 and 2. These are just estimates. We're just looking at it and saying it has to be somewhere in there, but we don't know where, do we?
No.
Good. Okay. Relative min and max, we call them relative because do I have more than one maximum in this graph? Yes, we now can have more than one max because we're not just a parabola. So I have a relative maximum in two different spots, yes? Somewhere between what?
6.
Like, I would say like -3 and
One.
-1.
Yeah.
See that? Somewhere between there, that's going to hit a max and come back down, isn't it?
Yeah.
Okay, so between -3 and -1
And then between 1 and -3.
and 1
Or
and
1 and 3.
1 and 3. Does everyone see that?
Yeah.
I don't know where it happens, but if something's happening in there in that period of time. Now the only way I'd know better is to do more points, right? And I don't want to do more points, do you? No. Okay, relative minimum.
Somewhere between -4
Negative.
and 2.
Gonna be between -1 and 1, isn't it?
Yeah.
Yeah. We said the turning point was between -1 and 1, so somewhere between -1 and 1 is our minimum, isn't it?
But
But what?
You got it.
what about the
No.
left, the
Yeah, what
negative?
about the?
Your point is -3, -11.5. pipes. That's.
Okay, but those, what happens here, guys?
They just keep spreading outward.
Okay, so are they ever gonna have a minimum if they keep going? No. The ends can't be minimums.
We
Okay,
have got
A
to
minimum
find
has to be I go down to it and then come back up. Got it? So can going up be maximums ever? No. Okay, because those don't have ending points, do they? Okay, so what else do I need?
The average rate. of
Average
change.
rate of change. So these are what? -2 and 0 are what? There's X's or Y's? X's, so I need the Y's. Did I do that for myself? Right there. Correct?
6 and 2.
So I need the average rate of change, which is the same as the
8 rock.
slope. So 6 minus 2 over -2 minus 0. Could I have written it 2 minus 6 over 0 minus a -2?
Yes.
Yeah, as long as these line up and down, right?
Uh-huh.
So I get 4 over -2, so I get
2.
-2.
Why did you choose -2, 6, and 2?
Because they tell me the x's.
Oh, okay.
They tell me the x's, and that's why I put -2 in my, whatever they tell me to look for, I always put it in my
I didn't read
table.
that part.
Every time I do, because I don't want to do it. What if they ask for 3, 7? Well, I put 3, 7 in my table, wouldn't I?
Yes.
Because I don't want to have to do more work. Yes, Evan.
Mary's rest.
Yes. Okay. So how did I start this problem?
I put in numbers in the thing.
In the table, right? And I filled in my table, and then I sketched my graph, and then I went and I just found. Now, there are lots of good right answers, but there are definitely wrong answers too, right?
Yeah.
So just make sure you're making some good guesses, okay? How many you got? 2. Now, I do have one more in here. I don't want to do it right yet. If you guys want to come back to it, I'm happy to come back to it, but I want to get to the next one. Got it?
Cool.
So, then you have one of these. I like these because all I have to do is do what they tell me to do. That's it. They're telling me how to draw this graph. They're telling me that the graph is positive. That means it's what? Above what?
The x-axis.
Above the x-axis, between -infinity and -4. So that means -4 has to be a what?
A Y.
An x-intercept. I know that -4 is an x-intercept because it says it changes right there, doesn't it?
Yeah.
They change from positive to negative at x-intercepts. Okay? So that tells me it's positive. So it's up here. So I just put a plus. And between what? -1 and 4. So -1 and 4. So I know those are both x-intercepts, correct? Following what I'm doing, right? Okay, then what's the next thing it tells me? Okay, it says negative between -4 and -1. Well, obviously, if it crosses the x-axis, it has to go negative, doesn't it? So it's negative down here. And then it tells me it's also negative from 4 to positive infinity. So it would be negative where? Over there?
Over there.
Okay, can you see what this graph is going to already do?
Yeah.
Yeah, it's going to come from positive infinity down, up, and then back down. So what degree is this function?
3.
Well, it's odd. That's all I know is it's odd, right?
Yeah.
Positive or negative?
Negative.
Negative. So I know it's an odd negative already just by these positives and negatives, don't I? Okay, so the next one says it's decreasing from -infinity to -2.67. So decreasing means it's coming down, yes?
Yeah.
So at -2.67, which has to be like a little, almost 3, right? We're just gonna call it here. It's decreasing to that point, yes?
Yes.
It didn't tell me the y, did it? Could I put it lower? Yeah. And decreasing from 2 to positive infinity. So that means 2 was a maximum, doesn't it?
Yeah.
Okay. Oh, and also means that negative 2.67 is a minimum, doesn't it? Comes down to it. Okay, so at 2, how far up do you guys want to go? Does it matter? Do I know for sure? No. Like right here, does that work?
Seems pretty high, but it'll work.
Okay. And then what's the last thing it tells me? Oh, it's increasing between negative 2.67 and 2. Doesn't it have to be increasing between 2 points where it's decreasing? Doesn't it have to be? Okay, so that means this graph looks something like
Yay.
that, doesn't it?
Confusing.
I have to go through x-intercepts, right? It told me where it was positive and negative. It told me it was decreasing to negative 2.67. So like almost right here, right? We said negative 2.67. And it told me it was decreasing from 2. And it told me it was increasing. This probably should go more up. Got a little shaky. So it's just kind of follow what they tell you.
Okay.
And you got one of those. Hmm? No, you have one of those. You have 2 of the last ones. And then you have 3 of the each types of the other ones.
Okay.
Do you guys want to do another graph one? Like where we do a table?
Not really.
Not really,
Okay.
but I'll ask if
So-
you need help.
Do I have any questions before I stop? Okay, I can put the book up here and you can start your assignment.